Welcome.
Great. Yes. Hello. Thank you very much for coming, everyone. Today, I have a clicker as well, right? Yes. So today I'll very quickly go through ANOMA, which, like, you need to do. It moves the notion of what we think of as blockchains, really. Like, it is not just like yet another L1. It is more of a distributed operating system that can run on a global L1, that can run on many different L1s, and that connects all these systems together. So rather than having to say that, well, I'm currently on Solana, or I'm currently on Ethereum, or currently on Arbitrum, you can rather say, well, I would like to do an action, and in code you define whether you want to execute this in something that has, for example, PBFT consensus, or something that has a Nakamoto consensus. Right, you can define all these things in code as intents, and then sort of the operating system abstraction handles that complexity for you, so that rather than you having to figure out how to use all these different systems, you can use one operating system. This also leads to the next point, which is it allows you as a developer to sort of, and I'll talk about this in a sec a little bit more, but like think of this very fundamentally as in like currently we're living in this pre-Windows moment where everyone keeps building programs for specific CPUs. And it's like you have to pick whether you like the IBM CPU or the Intel CPU. And if you want to switch to a different CPU, you have to check whether different programs are available. Like as a developer, like everything changes all the time, and you do not get the standardization effect that you get with ANOMA as a distributed operating system. So yes, with that. So currently we live in this very messy world where everything is all over the place. There's zero coherence to this. As a user, I mean, if you're active here, you probably have around 20 different wallets, because for some reason, this is a standard we evolved into at the moment, that all do various things in very slightly different ways. And you do not, and as a developer, this just gets worse. I mean, as a user, this is already bad, but as a developer, you go, well, I have to pick. Maybe I'm building for the EVM, but there's now 15 slightly different versions of the EVM. And like we're living in this ecosystem where it is very difficult to reason about the actual distributed systems properties that are at play here, right? Like it is relatively simple to reason about the properties that play in a single environment. For example, like Ethereum main chain, that's fairly standard. That's like fairly well understood how to do this. But it's very difficult to go, oh, my users live on 15 different systems, and they have various state and various components of those systems. And now how do I represent this to the end user in a coherent way? I mean, like one answer to this is, and I hope Mats isn't in the room anymore, I'm like, Dune is very cool, right? But it's like the answer that we're coming up with at the moment is like, well, let's just put a bunch of centralized servers everywhere, and then this problem magically goes away. Well, if the answer to the problem was more centralized servers, we didn't need any of these systems. Like, we knew how to build fast Postgres databases 20 years ago. This is like, if the answer to a problem becomes, well, let's just build an indexing service somewhere and someone just runs it, we've solved very little at this point. We've just like built the shittiest kind of database solutions known to man in the last 20 years. So this is the current state of the world. And with ANOMA and intents, this model fundamentally changes, because now all of a sudden you can think of this entire ecosystem as rather one unified operating system. It's a unified but distributed operating system where different parts of the operating system provide different guarantees. For example, some places will optimize for storage, some places will optimize for execution, but fundamentally you as a developer and as a user can treat this as a unified thing where you get a single operating system API that you can build against. And by the way, like for a lot of users, maybe the right trade-off model is actually that they want a bunch of centralized services, because like this is the trust model that they care about, and ANOMA is fully compatible with that. So like if you, it just makes it visible to the end user and the developer on what model you're actually in. Yes, this is very important because everyone is building intermediaries, and ANOMA is a distributed operating system. It's a development interface. It's not an intermediary. There's never a specific ANOMA instance you must send your thing to, right? Like there's no specific global ANOMA L1 that you must send your intent to. Where you want to send your intent depends on like the user's local trust preferences, essentially. Or like if they want to use ANOMA as an operating system on Ethereum, they just have to send it to nodes that interact with the Ethereum network. If they want to use it on the global L1, they interact with the global L1. If they want to and I'm a big fan of like sovereign things. So if they want to run this like for their local village, they only need to interact with people locally over, for example, some mesh networking that they're running locally. This is all compatible with this. So there's no intermediary, because especially with the chain abstraction people, I mean, a lot of people are saying like, well, we get rid of all this complexity by just introducing yet another middleman, and it's another middleman. Even if that middleman is decentralized, that doesn't really change the fact that now we've just added another hop into the trust model. Whereas here it's like, you pick which servers you want to talk to, which nodes you want to talk to, and you send your intents there. Yeah, it provides a level of abstraction that is compatible with existing chains and VMs. And this generally means that anything that's expressive enough to at least verify a recursive zero-knowledge proof will work with ANOMA. I.e., you can deploy the operating system, you can deploy ANOMA to those systems. You can deploy ANOMA, because ANOMA in the end is just a large recursive rollup, or like recursive circuit essentially, where you can, as long as you can verify that circuit, you can run this wherever you can verify the circuit. To deploy to things like Bitcoin, this may get harder. I don't know, the Bitcoin people are doing crazy things though with ZK at the moment, so we'll see where we get there. Yes, and fundamentally it enables a new paradigm of intent-centric applications. And this is really like, I mean, I've focused a lot here on the distributed operating system part, but one of the other core innovations of ANOMA is it's fundamentally intent-centric. It is not transaction-centric. It is, and this really just maps better into what users actually do. Because when Bitcoin came around, we lived in this world where like I go to a store and I'll give someone some Bitcoin and they give me some milk. That's a fully balanced transaction where I just do a payment, right? But nowadays, like 90% of all the use cases are, I have some A for B, who else has something to settle with, right? Like I would like some ETH for Bitcoin, who has some Bitcoin for ETH? But those things aren't transactions, they're fundamentally intents. They are partial state transitions, right? Where I cannot directly settle my intent. And so if we came up with this is one of the other things that, so like once you have generalized intents, you also need a way to do generalized counterparty discovery. And for example, Uniswap is like the poor man's version of counterparty discovery, where we said, well, counterparty discovery is actually very difficult. You know what? We'll just dump all the state in consensus, and we have like the single global lock called a block time to do all global counterparty discovery. I mean, we're seeing right now this absolutely doesn't scale because it also makes no sense. Like if we're in this room and we want to do some trading, we should do this locally. We can like do our local counterparty discovery. If there are intersections between our intents, we can settle them locally. If we need to have access to more liquidity, we can sort of reach out, right? But the moment you broaden that sort of counterparty discovery space, that moment you take trade-offs around privacy, around security, around actual latency. And like I like to joke about this, but no system can be faster than ANOMA, because ANOMA fundamentally like is deployed to the scale that you care about. It's scale-free in that sense. Like Solana can never be faster than this, because no amount of global consensus can be faster than us running some local consensus, right? And like, if the only thing that we need is some local consensus to do some local settlement, that's all we need. And this will always be faster than going, I mean, it's at least going to be what, like 800 milliseconds faster, depending on speed of light conditions around like how fast we can get to global consensus. So even the fastest thing is always going to be fundamentally limited by the speed of light constraints. This also comes to the other thing. I think blockchains weren't, like, this industry wasn't there to solve the problem of like, how do we do really good globally decentralized things. Like the idea was like, we wanted to be resilient and resistant against capture. And like, the answer is not like, well, we have this big thing that's very hard to capture. The answer to true resilience is we have many local things that are very hard to, in uniform, compromise, right? And this comes from, like, my thesis is fundamentally that sort of on the eve of World War III, Bitcoin and Ethereum just halt because most fiber goes away and global consensus is going to be shot at that point. And so like you want to have systems that are resilient in the sense that they are capable of adapting to the actual underlying topology that's currently available. Yes. Why does this matter for Ethereum, though? And why does this matter generally across the space? Well, because it allows you as a developer to fundamentally write one application where the user then makes a choice, where does this application run? In what specific execution context does this application run? But so you as a developer, you don't have to make the choice, oh, I'm going to target all the users on Arbitrum, or I'm going to target all the users on Optimism. You just make the choice of like, you build an application against the operating system, and then the users make the choice, because some users may want to be on Ethereum, some want to be on Arbitrum, some on Solana, someone may want to be on multiple things at the same time, right? And so now as a developer, you don't have to make that distinction anymore. Like, you just build an application and users to pick where the runtime is actually happening. It also means that you can treat all underlying chains as one unified system or one unified chain. To you, you're just thinking about like, there is one operating system, and of course different components have different guarantees, but fundamentally you're not treating them as like heterogeneous components, but you're rather treating them as like, this is one homogeneous development environment that you're working against. You also get unified intent liquidity, and this is, I think, actually incredibly important, because like, I as a user don't want to go manually hunt for where I should be trading ETH or BTC. I just want to say, like, I would like to do some ETH or BTC intent, and honestly, give me anything out of like these 6 acceptable options, maybe like Ethereum and Solana, or like and near, and wherever I get the best price, please execute me there if it's like in under 5 seconds of execution, right? This is sort of the idea here, that you can describe your trust preferences or like your constraints for what you want to do, and then the system sort of exposes this to the developer so that solvers can then come and pick this up and go like, okay, like, I have these constraints and I will decide to settle that guy on Solana right now because this is going to be the fastest. And I think this is like the really big unlock, because fundamentally, none of us are going to explain to any normal person outside of this room how any of this stuff currently works. Like, we're living in a ridiculous world where there's like 500 different systems that all work in various slightly ways, and like, my parents will never be able to interface with this level of complexity. So we need something that is just going to be easier to understand and that provides some sort of unification here also for the liquidity. Yeah, and you get unified DevX and UX. And the other big thing is, I was joking a little bit earlier around sort of the, well, if you run into a problem, just put a server in front, just like run a centralized infrastructure provider, and like that solves some of your problems. With Anoma, you just focus on building your intents and building your intent-centric applications, and you don't have to worry about building additional infrastructure. Like, you don't have to worry, oh, where am I running my rollup sequencer as a centralized service, so that, because this is essentially what a rollup sequencer does, it's counterparty discovery, right? Like, where do I run this? How do I run this? You don't have to worry about, oh, do I need to run my own solver algorithm? Because fundamentally, this is also what a lot of these existing systems are doing. You rather just describe your application, you let the market and the sort of rest of the ecosystem handle all the other complexity. Yes, so fundamentally, it's a little bit of a recap. So we're here moving from a virtual machine to an intent machine. And this is, I think, like, historically, we've moved moved from this transaction-centric world with Bitcoin to this virtual machine-centric world with Ethereum and Ethereum-like things. And in the future, like with Anoma, we're moving away from this virtual machine-centric world to this intent machine-centric world. So fundamentally, a VM, I mean, it's very simple. I think everyone in this room should be broadly familiar with them. It has an instruction set, some program counters, different layers of memory, and importantly, it runs programs sequentially. So an example here is like the Solana virtual machine, the Ethereum virtual machine, you name it. I mean, at this point, we have probably tens of different virtual machines that are all kind of similar. This also, by the way, includes all like ZK VMs. They are fundamentally the same model, except now we're running some proof over the actual execution trace. And so, what is an IAM in comparison? Well, it takes a batch of computes valid possible state transition, and then selects one according to some criteria, and then updates the state transition, updates the system state with that state transition. So you can imagine this if, for example, there is like 6 individual intents that aren't individually settable, right, because they're partial state transitions, but you take all 6 together, you put them into a batch together, then they form a fully balanced state transition, and then you can update the world state using this. And so one example here is, and I think the only one so far, albeit we will see more and more of these things coming up. I mean, we saw this with the EVM. The EVM was the first, and then like a year in, we started seeing like things that had slightly different trade-off criteria is the Anoma resource machine. The big thing to realize is because we all live in this like weird PvP battle where everyone's like, my VM is better than your VM. And I like, well, all your VMs are exactly the same. They're just like different colors. And I don't know why everyone keeps fighting over the different colored VMs. Like the intent machine and the normal resource machine, like it needs to run on some virtual machine. It's a higher level of abstraction to make our lives easier. It is not there to replace, for example, the EVM. It does something fundamentally different to allow us to do new things. Yeah. So the one thing I would like to cover here is a little bit that around limited data protection. And this is, I think, probably long-term the single biggest hurdle we'll be facing as an industry. Like, I will never be able to convince my parents to use any of these systems I'm working on if their neighbors can see whether they went to the pharmacy or what they bought in the supermarket, right? Like, and I think this is just a very fundamental constraint, because most people deeply care about their like local privacy guarantees. They don't want all their neighbors to see what they have in their bank account. Otherwise, like the Venmo thing where you could like had to pay someone to tweet about it would have actually worked in practice. And like everyone would be very okay with like open sourcing all their bank statements. One of the big things is when we say, well, we'll end up in a world of programmable data sovereignty, data moves to edge devices. So instead of, currently we live in this world where like there's a large blob of data in the middle and then we all do some compute over this large blob in the middle. This is A, super bad from a privacy perspective, and B, super inefficient from a compute perspective. And so like, we're moving to this world of like more and more data living in edge devices, and intents are the right way to represent this. Like it allows you to represent edge device compute essentially, where you're like, I have some local state and I'll produce some proof of this local state that is also referenced in a Merkle tree somewhere globally so that other people can agree on. But we don't need to sync these global state blobs anymore because a lot of this data just lives locally. So this is both useful for scalability, but it's also useful for actually data sovereignty, because like data lives on edge devices and users make their own choices on under what conditions are they willing to reveal this. And for example, if you still live in the world of, intents are just limit orders, I mean, A, you're wrong, but B, also, one of the interesting things here is that you can never like be fully private if you want to trade. You at least have to reveal to someone some intention about like, I would like to do like Bitcoin for ETH. If you're willing to go, the only thing you're doing is like, I have this intent, I'm telling you nothing about it, you will have a very hard time getting this settled. This is sort of just like, in order to enable counterparty discovery, you will need to reveal some amount of information, but this is what like programmable intents allow you to do, where you can say, I have all these state keys in my intent, and I'm only revealing 2 of them, and the rest are committed to in ZK. Yes, and it also moves us away from the centralized counterparty discovery model to more of a decentralized counterparty discovery, where, and I didn't speak too much about this, but composability of generalized intents. One of the big reasons why you have to deeply care about, like when you think about like we need an intent-centric system, we need a composable intent-centric system. Because if intents aren't composable, like if I have A for B and someone else has B for C, and a solver can't collapse this into A for C, it essentially means that there must be a mega solver globally that settles, that like does all the solving. Whereas if you have composable solving, it means that we can have thousands of solvers that each like specialize in their own individual niche to do like the step, to do the collapse from like A to B, B to C, collapse into A to C, and then send it off to someone else. Yes, and you can really like, you are not limited here. You can describe whatever you want. You can say, I would like to only trade some ETH for Bitcoin if the weather is nice in Paris, and if the weather is bad in Zurich, I would like to dump everything and go long like CHF. You're allowed to do this. Like, this is like, honestly, this is up to you as a developer, as a user, what kind of complexity you would like to express. Yeah, and so what does this mean? Intents and dApps written with ANOMA can be ordered, solved, and settled anywhere. This can be settled on Ethereum main chain. This can be settled on any L2. This is fundamentally, it's a user choice. Maybe it's a side note here. As like protocol architects, we can describe actual protocols and like describe how they work. It is very difficult to enforce a specific topology. And so as a result, ANOMA is very topology agnostic. Like if everyone wants to run this on one single server run by the one world government, this is still the right architecture for this. This is fine. You can run this also like, essentially like topology of the underlying network ends up being much more of a user choice on whether many people have many different trust models, for example, or like have many different local latency preferences. But in the end, like ANOMA is very topology agnostic. Users pick how they want to deploy it. Yeah, and this is what this ends up looking like. You have users and developers on the left. Then you have a bunch of P2P nodes that gossip these intents around. They can require some sort of payment. They can allow, users can stake here and then, so for example, get guaranteed bandwidth over time, for example, like 10 free transactions a month. This is all like something that you can build on the application layer, so that user experiences actually become very, much more valuable and like much easier to do. Then you have a bunch of solvers that say, well, we have all these intents, what are the intersections here? And then those are settled somewhere according to where the intents sit. Yeah, just very quickly at the end, what kind of novel dApps can you build here? Well, the thing that I'm very excited about is next generation decentralized exchanges that are fundamentally multidimensional. So order books aren't predefined. You just have like a n-dimensional matrix of order books where every new intent adds a new sort of like slice into the order book, and you can solve across that entire like n-dimensional cube. You get fully privacy-preserving stuff with this. It's going to be fully decentralized because there doesn't need to be a single global solver that does this. You can build very cool things like credit clearing. Like if you like this, check out Cycles.money. Rather than each of us wiring money around, we can just like net this out at the end of the day. I mean, this is way more efficient. This is why the banking system actually does this in practice at the moment. And then you can also build things like public signal to, rather than being supply-driven, be demand-driven. Yeah, we just launched DevNets like a couple of weeks ago. If you're a builder and you're interested, hit us up. It's cool. The entire software is open source, so please check it out. Also, it's written in Elixir, which is way funner to write than any other language. If you haven't checked out that language, please check it out. It's cool. And yeah, then testnets are, I think, coming in the next couple of weeks, like public testnet and then mainnet towards the middle of this year. Yeah, this is it. You can find us on Twitter. You can read the white paper. It's cool. Thank you very much.